Welcome to the August Raleigh Astronomy Club indoor meeting. We're glad to have you here. We're thankful. We got a good crowd. We got a great speaker. We're going to support him. All right, safety. Let's get the thing. Just think of me as your flight attendant. So, our safety. So, one of the things we have, what? One of the things we have to do is quick, identify room hazards. We have cables all over the place. Now we have cones, which I just tripped over one. So make sure you don't do that. Watch bags when you get up. If it's light, you know, usually we dim the lights so we don't want anybody to trip over anything. Anybody have a CPR? Come on, somebody's got. Yes, we finally have CPR people. All right, you're expired, but we have current. You're expired. Mine is expired like 20 years ago. All right, so who wants to call 911? Not me. Okay, Anna's going to call 911. Let's see. The fire equipment, we have a fire extinguisher over here. And I think there's one in the hall too, but there is definitely one over here, and the big one here is do not go out of the emergency exit. You cannot leave this with this by stairs. Somebody set it off a couple months ago and it was running when we got here. So let's not upset the museum that way. If there is an emergency, then we can go, but please take the elevator when you go up, and you cannot go through the parking garage when you leave. And well, yeah, but I meant if there's an emergency, we'll go out the stairway. There's an exit here, there's an exit here, and you can go out through the parking garage. It's pretty sure. All right. Just don't do it in a normal leaving the meeting because that causes a big ruckus. We don't want a ruckus. And anybody at home, hi, welcome. And please be careful. Don't get so involved that you trip over your chair or anything. We don't want that. All right. So safety, everybody's good. Dana, Naveen. Oh, somebody needs to do that. Oh, and here we go. Here you see the safety exits. So if everybody's clear, we're good. All right. Let's see. Upcoming events. Tomorrow night at Howell Woods is the Person Media Shower. Is anybody signed up? There's like 2 people signed up so far. We need more people because we have families camping out there, and there'll be kids and families that are on the property, and they'd love to come and look through your telescope, and maybe you'll catch some persons. Please see. Oh, go ahead. Do you want to talk about it? Yeah, go ahead. I was going to ask. I was going to throw it to you, Dana.
So for the Howell Woods tomorrow night, if you come we'll get there about 7:30 until about 10:30 is outreach. And at 10:30, I'm going to go in the back of the backfield away from everybody and observe. So it'll be like a little mini RAC obs or something, but it's only astronomy club people. So the kids and the families and all that stuff that's going on the camping, it won't be back there. There's no campfires. And we'll be down a hill and in the back, so it'll be dark. So if you want to go, you need to sign up.
No, and no, yeah. If you did not hear that, no, they will not shut off the lights. We have to work around it. Okay, the 22nd is rake-ups, and we're in the process of getting some commitments from some key holders. Email will go out Monday or Tuesday confirming stuff. The August RAC class is canceled. Our instructor has COVID, so everybody think good thoughts for Jim Presley. Jim, if you're on Zoom, I hope you feel better fast. First Fridays, RAC indoor. It's pretty self-explanatory here. The big thing we've got coming up is the International Observe the Moon Night, which Mr. Blake, do you want to talk about anything about that? Okay, all right. Details TBA. And then big one, I'm supposed to remind everybody, is Staunton River Star Party. I know, yay! If you have not signed up, please do. If you don't stay on the field and you need a campsite, I will say they're filling up kind of fast. So I would do that. All right, and now the reason that we're here. Oh, wait a minute, sorry. Oh, I forgot. Yeah, I had done that before it got postponed. So, and you need one more of. You think maybe, okay. The Willard was postponed this week because of the crummy weather, and it will be the 20th, which is a good time. And even if you're not coming as a volunteer and you just come, it's always a fun time. Okay, anything else? Nope. Okay, so Mr. Brandt, we're so glad you're here. Do you want to come up and give him a big hand? Oh, sorry, you're all set.
Am I hot now? I'm hot now. Yes. Okay, good. All right. You see this last sentence down here? Astronomy Days is one of Ken's favorite outreach opportunities. Thank you, Raleigh Astronomy Club. You guys show us how it ought to be done. Thank you. And my first slide is going to speak to that, actually. But that date, by the way, is a little bit revised. It should be 12/26, unfortunately. The district made the decision. We're part of a larger high school. And so you can see the high school behind the cylinder there. The cylinder is the body of the new planetarium. And I was doing a little joke there, budget cuts have gotten so bad that they're actually coming to take it away. See the flatbed, so very astute camera angle there on my part. I'll go ahead and take credit for that one. If you could scroll up a little bit so we can see the schematic. All right, the schematic I wanted to show you. You can see the cylinder up there at the top right of the image. Fortunately, I forgot my laser pointer. So that minus 2 demerits or 2 points off for Gryffindor for, yeah. Oh, perfect. Okay. Perfecto. All right, that button right there. Okay. Right there. All right. That is the planetarium. That's the inner body of it. 40-foot dome, 77 seats, 8K projection, 6 video projectors, 1 star ball in the middle of the room. To say this is a state-of-the-art facility is making Moorhead look bad. No offense. If anybody's a fan of Moorhead Planetarium, we're going to have them diced on the image quality piece because my images only have to go over a 40-foot dome. Their image, same exact system, 6 projectors, 8K resolution, has to fly over 67. It doesn't take a rocket scientist to figure out there's more pixel depth in a 40-foot dome than in a 67-foot dome. So they're going to be coming down to see us to see what their visuals should look like, basically. I'm just kidding about that. Moorhead is, I have great respect for Dr. Boyette and the staff at Moorhead. They do great work. So I'm only messing around. That's whole science festival thing, man, that's another one of my favorite outreach efforts right there. The thing they do every April. Can't say enough good things about them. Please scroll down. Just out of curiosity, how many people online are there? Okay, well, don't worry about it. I'll just, okay. All right. So big deal about supermoons, right? All the media hype is about supermoons. It's great. Okay, one small problem. Not a real visual difference. I'm going to show you what I'm talking about here. Please, and this is going to be important throughout this presentation. If I do it, you do like me, please. Okay, if you're at home online, I don't know where the camera is. Where is the camera so they can see what I'm doing? Is that it over here? Is this it over here? Oh, okay. So there's one looking right at me. Okay, good. All right. So basically, I want you to take your thumb, put it out at arm's length, and have a look at your thumbnail out there. And I want you to compare it to something along the wall that you can pick as a background item. Maybe the word, I don't know, one of the words up here might work for you up here. For me, the light switch is working pretty well. Now, I want you to just relax your thumb. Let it hang natural. Do not exert any muscular force on it one way or the other. Now, I would like you to drop your thumb down onto your hand, like so. Like so. So now your thumb is resting on your hand. Tell me about the size of your thumbnail now. Bigger or smaller? It should be smaller, right? Can you tell, honestly? Put it against your background. No, I can't really tell. Now, okay, now I want you to work your muscles really hard now, and I want you to flex your muscle here so that your thumb is as close as you're to your eyes. You can get it without moving your elbow. No fair moving elbows. Does your thumbnail get bigger? A little bit. About 10% bigger. How about that math? Because it's about the size of a supermoon over a regular moon, isn't it? All right, then. So that math works out pretty well. I'm going to tell you right now, scale off to the side. Kick that right out the window because we're going to start talking about the scale of some of these activities. All right, we can go nuts. All right, because for example, if I'm going to do this whole thumbnail on the moon thing, the sun would have to be in the theater, okay, on the stage where the screen is. We're one of those little dung beetles crawling out of what's his name? Sure. It'd be about the size of that dung beetle, or about the size of him. Yeah, that's the size of the wall. Yes, you're right. Okay, so go ahead and scroll up, please. Okay, good. Now let's look at this image here. This image is courtesy Dave Hofstetter, who was the director of the Lafayette, Louisiana Science Center and Planetarium, one of my SEPA planetarium buddies, Southeastern Planetarium Association. So pull up the moons, please, so we can see the moons on the screen. There we go. Okay. I have door prizes, by the way. And these are all going home with you. Anything that doesn't go home will be staying with the two ambassadors that I know are here. Are there any other solar system ambassadors in the house? Okay, well, good. We have two. All right. What I want you to do is to write down or put in your head the number of the moon you think is the super moon. And also, oh yeah, I didn't coin the phrase for the mini moon. Mini moon, you know, like Dr. Evil, mini moon. You have to be of a certain age to get that one. But you know, that was like 20 years ago. But 30 years ago, jeez, I'm dating myself. Anyway, all right. So let's see. Let's get volunteers. Give me a super moon. Number 12. Okay. How many agree with this gentleman? Number 12. Hold that because you're correct. Is that the only possibility? What else you got back there? Number 2. Very nice. Okay, please send this down to the nice gentleman in the corner. Thank you. All right, this is, by the way, what I'm giving out is the Dragon mission patch, the first Dragon mission patch to the ISS. So this is Dragon 1 right here. Okay. Any other supermoon possibilities up there? 11. Okay, I'm liking not so much. 4 maybe. 11, kind of. 2 and 12 are the winners here, guys. The clear winners. Now let's talk about mini moons, shall we? Okay, I know you've already got one, so I'm going to call on somebody else. Yes, sir. 9 is a mini moon. Hold that. I think you've already got one of those, don't you? So I'm going to give you something else. Hang on. Hold the phone. Stop the music. I got a set of Mars pictures for you from the Mars rover Opportunity. Okay, what do you got? Number 1 is the other supermoon. You've already got one of these, so I can't give you that. So I'm going to have to give you this picture set of Mars. Here you go. You're welcome. Okay, go ahead. All right, number 8, number 9, and number 1. All 3 of those are really good candidates to be supermoon, mini moons, rather. Okay? Okay, all right. No, that's okay. This is science class. You get to argue with the science guy. It's all right, please. Especially if I'm wrong. Please take me to task because I don't want to give out misinformation. That's the absolute last thing I want to do. So if I'm screwing something else, please correct me. All right, please. Please scroll up. All right, so when does this matter? When does the supermoon matter? Because boy, it matters a lot in this one particular circumstance. Okay, good. You're trying to bring in money for a PR stunt. Sure. Okay, that's one possibility. But I'm thinking a way more practical example like you might see in Egypt in 2027. There we go. Yes, sir? Yep, the eclipse. All right, or moon landing. Moon landing is also possible that year. But in 2027, like you say, that is possible. That is going to be a super new moon. And it's going to be the longest totality in modern history. You have to go to something I looked it up yesterday, it was somewhere 743 BC to get a longer window totality here. The maximum, the absolute max you can get is about 7 minutes and 30 seconds of totality. That's the biggest possible supermoon and the smallest possible sun. So what would be a good month for that to happen in? Ooh, you've already got one of these. I'm gonna have to give you something else. Hold that. July or August, yeah, both of those are good. For the simple reason that's when the sun is smallest. It's furthest away, right? July 3rd, aphelion. So that's when you want your supermoon. You want your eclipse right around August, which is the one next year, or July, and you want it to be with the supermoon. So both of those situations seem to be coming up there nice. Yeah, your arm would have to be roughly 12 feet long to do this and to do it to scale. I figured that out yesterday. That's right. Okay.
Between $0.25 and $0.50 coin for super.
Oh, okay. All right. Interesting. That's pretty big.
Sun's much less difference. Between 94 and 500,000 and 91,500,000.
Right. Can you scroll up, please? Thank you. All right. One of the best opportunities I get as a planetarium guy is to answer questions from kids. So we're doing the eclipse spiel last year. Obviously, last year was all about eclipses because we had 2 of them in one school year. That's never going to happen again, okay, in my lifetime anyway. It's going to happen maybe in some of your lifetimes, but I will not see it again. 2 eclipses, 1 school year, boom, the planetarium guy, right? That gives me another year at least. But during that time, we're doing the eclipse thing, and a 3rd grader timidly raises her hand in the far corner of the dome. And she says to me, what's going to happen when those 2 hit each other to us? Hit each other to us. What's going to happen to us when they hit each other? I'd better get this one right, right? This is one of those you'd rather not fail if you're a dad or if you're a teacher. This is one you want to stick. I stuck it. One hand, it's pinky. Put it up here about nose distance away from your nose. Other hand, your thumb is going to do lots of duty today. Now your thumb is the sun. It played the part of the moon a minute ago. Now it's playing the part of the sun. It's going to be Venus here in a minute. So, stick around. Now you want to line these up so that your pinky just barely covers your thumb. So what are we setting up here? The solar eclipse, right? Okay, so without moving elbows, try to hit your thumb with your pinky. I double dog dare you, Miss Peter Pan would say. I'm going to stand here and watch while you don't do it, because you can't do it. Guess what happened in that room? A bunch of kids started to smile because that question scared not just the one, but now you got an entire room full of kids wondering what's going to happen when the sun hits the moon. Okay, very, very nerve-wracking time. And they start smiling. Eventually, a little girl who asked the question smiled. And she said to me, they can't hit each other, can they? Score. Score. This is where if I was like Mick Jagger, or I'd go on my knees to the far corner here. That was the goal. Top corner of the net, baby. Nothing but net. Boom.
Equals the distance from the sun to the moon. That's eclipsing it.
Oh, okay. Awesome. Please take me down a little more to the next item. Okay, Galileo was right. Can you scroll down just a hair so we hide Galileo's drawing here for a minute? That way. Whoops. The other down. There we go. Perfect. Okay, we want the big reveal at the end. That's what we're looking for. Okay. The quick version of this, now your thumb is the planet Venus. Now let's pretend that Mr. Ptolemy was correct. That is, in fact, a geocentric universe we live in. and everything goes around the Earth. Stick your thumb out here, please, again. Now, look at your thumbnail again, and again, measure it against the back wall of something. Now, I want you, without moving your elbow, that's key in all these, to slowly scroll your thumb back and forth, and I want you to look at the size of your thumbnail. Tell me about your thumbnail. Does it change size? No, it's the same size. Even if you do a little bit of variation for a super Venus and a mini Venus, it's still roughly the same size because it's going around the Earth just like the moon, right? But Galileo says, actually, Galileo's student Castelli, Benedetto Castelli, in 1611, writes Galileo and he says, Professor, he's one of Galileo's former students. He says, Professor, I think you might get really good success proving your model of heliocentrism if you follow the phases of Venus during this apparition. Galileo did what he was told. One of the reasons why he's the greatest of all time, he's smart enough to listen to his students. That's a savvy thing to be as a teacher. You got to be able to listen to your kids. So we're going to pretend that this water bottle is the sun. Okay? And I am going to go over here on the far side of the sun, and I'm going to put Venus up over here. Now, I would like you to put your thumb back up and compare it to mine. Whose is bigger? Yours is bigger. Why? Because this one's far away. There's another correct answer here. Or your thumb is closer. Both of those, the commutative property over distance, they both work, okay? So either answer is correct. You guys have run out of prizes to give you guys. You guys have gotten everything. Here you go. There's the Europa bumper sticker, or, postcard. Okay, so if you'll scroll up a little bit, this is what Galileo saw. Huh. So based on what you've just seen with my thumbs and your thumb, and based on Galileo's drawings of Venus, do we live in a heliocentric or geocentric universe? Heliocentric. Bangarang, as Peter Pan would say. Bangarang. Because there it is. That's what got Mr. Galileo in so much trouble, because now he was convinced, and now he was going to make a point. He was going to make several points, one of which was done in the discourse dialogue concerning the two chief world systems, where he basically made the Pope out to look like a fool. That then and now, that doesn't work. So that didn't work very well for him. Anyway, can you scroll down, please, to the next one? Okay, the moon on a string. All right. Let's see. If this is the Earth, where is the moon in this room? Where is the moon in this room? Okay, way past the back of the room. Anybody want to go for up here somewhere? No, okay, good. I forget, I'm working with a very savvy audience here. So this is not my typical class of third graders. Thank you very much. Appreciate that. Oh, well, there you go. We got one. Okay, that's good enough. Excellent. Or roughly 25K in circumference. Okay, 1,000, 25,000 circumference, ballpark. We're going to use ballpark numbers here. Remember I said scales out the window? Scales out the window. So screw exact numbers, we're not using them. Sorry. Okay, so let's go here and measure the length of the string around the Earth one time. That is 25,000 miles. Now, what is the average distance of the moon to the Earth? To the nearest 250,000 miles, please. 250K. There's a numerical relationship going on here. What's that numerical relationship? 10x. Very good. So in order to do this, and I'm going to ask for your help, please. I want you to hold this just like this. Okay, so now we have one. This is one length. Okay, 2, 3, and 4. Oh, thank you. 4, 5, 6, 7. Oops, there it goes again. Okay, oops, sorry about that. 8, okay, 9, and 10. Okay, now we're going to figure out how far away the moon is from the Earth. So what I'm going to do is I'm going to come over here with this end of the string, and you, sir, are going to walk around to the back and hold the very end of the string right here. Hold it here. Now, you're going to go all the way back there as far as you can go. Okay? I'm going to put this end on the Earth. We'll put it on the North Pole of the Earth. There we go. And that's the one thing you have to watch out for is your string knotting up on you. Okay, keep going. Yep. Okay.
Diameter of that globe.
Good question. I don't. Yeah, it's about 15-ish. Okay, so there we are. As this gentleman, who said it would be outside the back of the room? Yeah, one of the Steves. Okay. I'm just going to leave this here. I'll deal with that later. All right, but I need to hook Steve up. Whoops. That's the other thing there. Thank you so much. All right. And Steve, give you a set of postcards from the Mars rovers. Good, thank you. All right. So this is an excellent way to give students the idea that the Apollo missions and the Artemis missions were really doing something here. When they went to the moon, it wasn't just going around the block. On my globe here, where would the space station's orbit be? Somebody raise a hand so I can just shout a door prize here, please. Anybody online? Got a shot at this one? What I'm asking here is on my globe, where would the space station be? How far above the globe would it be? Who said the inside of the frame? Where are you at? You got it. Yes. The other Steve. Steve's for the win. Okay, very nice. Okay, yes. It would be inside that brass ring, roughly where this little green guy is here. About halfway between the brass ring and the surface of the globe. Okay, very, very short ride, so to speak. What, 8 minutes? Okay, you get from here to there, 4 days to get to the moon. Okay, when Christina Koch, oh yeah, good old Christina here. When Christina Koch goes to the moon next year, she will be the first woman to ever go to the moon. So that's very cool. I just think that's worth mentioning.
Thank you.
And she graduated NC State. Thank you very much for reminding me of that. This is always a, yep, go Wolfpack. Okay, so if you'll scroll up again, sorry. Yeah, so we are on page way back out here.
Sorry, that was my fault. I was telling him it's inappropriate.
Oh, okay. All right, now we're going to talk about shivering. I did say shivering, the very word, yes, shivering, as in what you probably aren't doing right now because it's too dang hot. But we can use shivering to walk our way to tidal flexing. Forearms. Please take your forearms and put them together. Rub them together. What's happening in there? A little friction action going on there. You can also talk about meteors with this, by the way. We're talking about the Perseids tomorrow night. You can also talk about friction. Well, this is what happens if this is muscle fiber A and this is muscle fiber B. This is what's happening when you're shivering. They're rubbing against each other involuntarily, trying to keep your core warm, right? Am I explaining the physiology correctly? Any of the medical folks out there? If I'm not doing it right, please help me out here. Okay, so that's the basic physiological mechanism for shivering. Now let's talk about Europa. Europa's got a surface that's exposed to about minus 200 degrees. So if water's up there on the surface, it is frozen. If it isn't frozen, it didn't stay liquid long, if you know what I'm saying, right? But long enough to coat the surface of Europa with fresh water. all that brown schmutz that's up there. I can't wait for Europa Clipper to get there and find out what that is. And to get some close-ups, see if there's any little bodies sitting there in the ice. Who knows? Okay, so underneath that ice, we all know there's a global ocean, right? So if now you're putting your arms like this, down here is ocean, up here is air. When you rub your arms together, now the ice breaks, the water comes out, and the water into here melts because of the friction. So you've got this whole mechanism going on thanks to Jupiter and the other Galilean moons, mostly Jupiter, and its gravity that causes Europa and Enceladus to do this tidal flexing. And you can tell about the tidal flexing because there's cracks all over the surface of both objects, especially the south pole of Enceladus. Oh, sorry. Okay, can you scroll up a little bit? Okay. What's the North Star got to do with it? You knew I was going to make you stand up at some point. Please stand up. Please stand up. Please, if you're able, please stand up. Okay. Now, I want you to pick a point directly above you. We're going to pretend you are on the North Pole and you are looking straight up. I want you to point at that spot, whatever that is. Now, without being very mindful of where your surroundings are, watch out for like your umbrella, for example. I want you to slowly turn around so you're doing a complete circle. Yeah, you can look down if you need to. Please do. Please don't fall. Yeah, remember safety, all right? I do not want to have to activate the 911 call, okay? Not cool. So, but you see what's happening here. Now I want you to do it again, and this time pay attention to your surroundings as you go around. Pay attention to the background, to the walls, to the patterns you see. Okay, now if this is Earth going through the sky in terms of a year, now you're talking about the different patterns of stars we see in the sky at different times of the year. Okay, and of course, if you're out there in December, you're seeing the entire panoply of northern hemisphere stars over the course of a 24-hour day, right? So you'll be able to tell where you're at. Okay, so that's a really good way for me to tell my students why the North Pole where the North Star, doesn't move, and why it stays in the same place in its orbit, because it's right above you, basically, if you're on the North Pole. Please scroll up again. Okay. All right, now this activity I borrowed from NASA's Mars Engagement Program about 15 years ago, and I'm still using it. So what I need is 3 people that would like a door prize. 3 volunteers. Gentlemen, come on up. Yeah, we're going to go to Earth and Mars. Come on up, sir. Okay, now I have to give you some special directions. When it comes time to try and fly to Mars at opposition, your job is to play volleyball. That is, you're going to knock down anything that comes through your airspace. Okay, so you stand right in the middle of these blue cones. Here's the sun. Wave and smile at everybody. Okay, which one of you would like to be? Okay, the guy in the blue shirt, blue hat, you're Earth. Come here. You're going to stand right here next to this blue cone. And your job is, every time I say go Gators, you're going to go to the next cone with that blue wrapper on it, okay? Come on over. You're Mars, okay? You get the cool job. All right, you ready? Every time I say go Gators, you're going to go to the next orange cone, okay? All right, now, what I want you to do is I want you to take this pad, this sticker, and I would like you to gently place it on Mars's left knee. Left knee. No, don't stick it. Just point it. There you go. And a little lower. There you go. Pretty close. Pretty close. Within the landing ellipse, I think. We'll take it. All right. So nice time to launch missions to Mars, right? Very economical fuel. And what about Mars's brightness in the sky in this orientation? Bright or dim? Really bright. This is opposition, right? Don't get brighter than this. All right. Okay. Go Gators. Good. Go Gators again. Okay, stop. I'm just going to go right to there. Okay, All right, now repeat that thing with the sticker. Can't move. You got to keep your feet on the cone. There you go. Now try and do it. Not as easy, is it? Not as easy. You got to throw it. Mars is cheating. Okay. All right. Go Gators. Go Gators. Go Gators. And go Gators one more time. One more time. So you're over here. All right. It's been a year. And look what happened. Mars is way the heck over there on the other side of the sun. It's actually about a year and a month. This is best done with 9 cones, okay, instead of 8 to properly symbolize Mars's orbit, but right now 8 will do. Okay, again, scale out the window. Okay, so I would like you to try and launch your probe to Mars now, please. And now it's volleyball time. So you go through it. Not easy, is it? Well, okay, here's the good news. NASA doesn't even try. As a matter of fact, during this 2 weeks when Mars and Earth on the opposite sides of the sun, all communication shut down. You know, when you get those beautiful panoramas, that's when they're taken, when Mars and Earth are on the far side of the sun from each other at inferior conjunction. Okay, go Gators again. Go Gators. Come on, one more. Go Gators again. And one more time. Go Gators. Yes, I graduated from the University of Florida, by the way, in case you were wondering. Okay, so repeat the drill. Look at that. Nicely done. Thank you very much. Can we give our volunteers a hand? Oh, very nice. Sweeping bow. Very good. Thank you, gentlemen. All right. So now we know you can't always launch rockets to Mars. If you look at, I have my college students that I teach online astronomy at UC Beaufort. One of the things I have them do is the Mars landing histogram, where they actually figure out, hey, they don't launch just whenever. They launch at this pattern. You know, every 2 years, 2 months, they seem to be launching here. Well, that's kind of the point, isn't it? That's what I wanted you to see. Yes. So please scroll up. Okay. So this is basically the write-up that went with the explanation I just did. So if you'll scroll me up a little more. Stop the music. This is the one we're not going to do tonight because we don't have sunshine. But what I do in the mornings, or anytime we're doing solar observing, I'll put a stick in the ground. Poof, gnomon, okay? And I have several, you know, those real estate stakes with the little flags on them. I have a handful of those. And at 9 o'clock, I'll stick a stick in the ground where the tip of the shadow is. At 9:30, I'll stick another stick in the ground. 10 o'clock, everybody starts showing up. And I start asking them, okay, hand them a stake. And I say, where do you think the sun's shadow is going to be in half an hour? And I get them to predict where the sun's shadow is going to be. Okay. Whether they're right or not is irrelevant. Okay. Really doesn't matter here. The point is we're doing science. Okay. We're actually making predictions and testing a hypothesis. Okay. Maybe I'm right, maybe I'm wrong, but we're going to find out. Okay. Most of the time, by the way, my 3rd graders nail the pattern. After they've seen 2 sticks, they know where to put number 3 in general. They don't normally put it on the other side of number 1. If we're going to number my sticks, 9 o'clock is 1, 9:30 is 2, 10 o'clock would be 3. They're not going here to the left of 1. They're going to the right of 2. So they're going where the sun is going to be in half an hour, or where the shadow is going to be in half an hour. And so that's really good. I'm pretty proud of that. And I do that, by the way, by introducing, in 3rd grade in our district, we read Peter Pan. And chapter 2 of Peter Pan, anybody know the title, chapter 2? Peter Pan? Chapter 2, yep. Ooh, this is a rare one right here. This is from the Galileo mission. So this is what we're shooting for right here, if you got it. Anybody? Okay, go ahead. Sorry, say again? Bless my marbles. Okay. No, it's called The Shadow. And it's all about Peter Pan's shadow. and how the shadow behaves. And we talk about shadow behavior. And we talk about how fanciful Mr. Barry had it, because you can't stuff a shadow in a drawer. Neither can a dog catch a shadow. And I'll do that. I'll do it with the third graders. I'll say, my shadow's right there. Have at it. Catch it. Go ahead. And you know, a couple of the guys, normally the guys, right? Okay. Okay. They'll go after it and they'll try. We'll be like, fellas, are you wasting your time here? Because you're not going to find this, you get this shadow. I promise I'm giving this out before the end of the day. You just got to figure out the question to ask. Okay. So this is a really good activity to do if you're doing solar observing. Okay. Just to give people an idea for how the Earth is moving, you know, and how that affects the motion of the sun. And hopefully you get, if you're lucky, you got the moon in the sky too, because then you can talk about how both objects move in the same speed and same direction. And then you can get the hint, maybe they're not the ones doing the moving. How about that? Go ahead and scroll up, please. Thank you. I think. And keep it simple, sweetheart. All right, this is easy. We're all going to stand up and go around the edges of the room, please. Unless you're manning the online thing. I'm going to go around the edges of the room. We're just going to stand up and make a circle. And our projector here will be the sun. Okay. All right, so the projector is the sun. And you are representing Earth. Your head is the Earth. Your body is the Earth's axis. Okay? So I want everybody to pat your North Pole. Say hi to your North Pole. Yeah. I got a good one, by the way. When I'm with third graders and mostly female teachers, I say I've got the best North Pole in the room, because there's actually, you know, like an ice cap up there. Anyway, sorry, bad joke. Okay, so one thing we do, if you want to simulate what a day is, I like telling the students I love mathematics, but I like easy math. Can we do the easy math, please? I want this in terms of the number 1. What is the definition for one day? Go. Oh, number 1, right? I wanted the number 1. 24 hours is correct, but it's not what I'm looking for. Okay, but good shot. Okay. What am I looking for here? You can go that way, of course. 1 365th of the way around the sun, or the time it takes to go all the way around on your axis one time. So go ahead and do a day, please. One complete rotation of your axis. Okay, revolutions are going around the sun thing. All right, which we're going to do now. All right, you ready? Okay, as we said in the Navy, right face. Right face. Right face. Okay, yeah, I'm talking to you. Right, you're the right, ma'am. And this is very good. This is fun because third graders, you know, you can imagine the kind of fun we can have with this one. Okay, I would like everybody to slowly tour the room counterclockwise. And don't trip on anything as you're going. So carry on. Go, go, go. Safety first. Now, we're going to go through all this all the way around. Yeah, please don't do that unless you're a ballet dancer. Please don't do that, because ballet dancers know how to do this, right? They know how to pirouette and keep their focus on one spot. I can't do that. Unless you can wear a tutu and you got the skills to match the tutu. Don't just wear a tutu and go. That does not make you a ballet dancer. All right, so we go all the way around and all the way around. When you get back to where you started, please stop. All right. Now you've just completed one what? Year. And I'll actually do this before we start. I'll walk around the room and I'll go Christmas, New Year's, MLK Junior Day, Valentine's Day, excuse me, Fat Tuesday, St. Patty's Day, Easter, Memorial Day, 4th of July, Labor Day, way over here to go to Halloween, okay, Thanksgiving, and then back over here to Christmas, right? So what I'm telling the kids is you are occupying Earth's position at a particular time of year. So what you see when you face around the sun, away from the sun, turn away from the sun, please. What you see is going to depend on where you are in your orbit around the sun, right? Whether I see screen, or whether I see display case, or whether I see bright projector, or whether I see clock and dark room, depends on where I am around the sun, right? As I'm looking, okay? And that's going to change throughout the year, right? And you actually stop them along the way. Now, Sherilyn Morrow and Ray Zawatsky, excuse me, did this thing about 20 years ago called Kinesthetic Astronomy, and the link is down here somewhere. It's can you pull up a little bit, because that we'll get to the link. Pardon? Great. Okay. Yep. So that's PDF. Sorry, this strung over one letter. So just highlight the whole thing, copy and paste it. But that's the full activity. It comes with props. You can do an east-west thing. You can talk about leaning over to imitate the North Star, Earth's orbit around the North Star. Not orbit around the sky, sorry, the North Star's position in the sky by having the kids tilt the same way all the way around. You've got to be in pretty decent shape to do that. I will tell you that. Okay. That's hard to do. Now, I wanted to finish this presentation with by turning it over to you all, because you all are experts in amateur astronomy. I know you've come up with some quick and dirty kinesthetic motions for yourself to try and explain something to somebody at the scope when you were showing them something and they couldn't understand, like, well, why are there spiral arms in this galaxy, or any one of 100. Why? This is one I thought of today. I was thinking, well, how would you show a transit of a planet, say, orbiting Jupiter, like, say, Europa? If I can do it right. Is my shadow of my thumb on my head at all? It's on my eye. Okay, good. All right. So right over the red spot. Very good. Okay. But there's another simple way to demonstrate what the eclipse would look like, or the occultation would look like, if you were or floating around in a balloon over Jupiter, watching this thing. So so any other ideas out there? Anybody else come up with something good that I can steal? Because that's really what I'm after here. I'm looking for the next good activity. Oh, cool. That's cool. That's really good. So a big gym, binoculars, and just have the kids do the phases. Excellent. That's okay.
As well, but model the solar system, both size of planets all the way down from like really small to like a huge ball type, and have the kids, one kid represent each planet, and stand out all those different systems.
Kind of like what you guys do between the two buildings on astronomy days, the scale models of planets and little pictures. Yeah. Solar system walk. Anybody else come up with anything good that? Yes. Yes, sir. That's excellent. That gives the 1 degree a day.
Moon is about the size, almost as large as the United States. if you were to put one side over Cape Hatteras, the other side would stop just before reaching California at 2,160 miles.
I hadn't thought, go ahead.
Those 300 or 400 yards away, baseball bat. Like,
Mhm.
see the ball hit.
Oh, that's cool. It's like being in a big football field and watching a punt. All right, well, thank you. Oh, go ahead. Go.
Hang on your lattice. See, put it on a table here. We get a little stick figure man. Do that later.
Oh, yeah, hang on. Just gave up the laser pointer. I know, right? Just when I thought I wasn't going to use it
And,
anymore. Here you go. It's in the middle.
We have the axis of the Earth pointing to where the North Star is. That's how it spins. You have a little man up here looking into the night sky. As you spin the Earth, the North Star will stay at the same spot, right? And
Mhm.
it'll be right above you, 90 degrees. But if you're viewing it, and you move the stick figure down to the equator as it moves around, what they'll see in the night sky is the North Star will be like at the horizon
Mhm.
at 0 degrees. And so we're kind of like right in between there, right in North Carolina,
Mhm.
kind of halfway in between. And so if you look up in the night sky, the North Star will be at like about 45 degrees-ish.
About 35, yeah.
And the degrees that it is up in the sky is your latitude on the Earth.
Mhm.
How far north you are based off what starts.
Exactly. Thank you very much. It's excellent. Anybody else? So I've got several good ideas I'm going to be working with here. Nice. Well, I want to thank you all very, very much. You guys have been an outstanding audience. But before I do that, is there any other questions about any of this?
Are you going to be after the presentation's over?
I think so, yeah.
Can we get everybody to go ahead and sit down?
Oh, yeah, sorry. Go ahead and sit down. I'm so sorry. Thank you. Thank you. Okay. Oh, well, go take me back to where I need to go. Let's rewind. Okay.
So if you, did I say something wrong? Oh, okay. So, Nicholas is asking, why is most of the scarring near the, poles on Europa?
You know, the Europeans are sending a mission called JUICE, and we're sending a mission called Europa Clipper that will be able to answer that question a whole heck of a lot better than I can, because I really don't know, honestly. Yeah, but that's one of the, that's why we're sending more spacecraft. We've got to find out. Yeah, that makes sense too. I never thought about that. Wow, yeah. Okay, that's a good one. Hadn't thought about that. Any other questions about anything?
You might get that.
Why, yes, you do. Here you go. All right, now listen up, you nice people. I have all kinds of goodies, and I'm going to answer the question in a second. I've got all kinds of nice goodies up here. I do not want to take any of this home. Okay, if you have teacher buddies, okay, this makes a really nice half a bulletin board, right, for somebody. Also, I've got stickers and Europa postcards. This is something I would welcome you to take a few of. And when you see someone showing this particular character trait, you give them one, right? You say, you are persevering, and I see you. You know, I mean, this is really great with guidance counselors and teachers. They love this because, you know, if they got a kid that they really want to single out for something special, but they don't want to make a big announcement of it, they just kind of, you know, slide them a poster real quick. Yes, ma'am. You, oh, questions. Yes, questions about anything. Go ahead. Microphone. All right, gotta wait for the mic. Do we have any questions online? I wonder. Oh, it was online. Okay, good.
Do you think Planet X is real?
I'm gonna throw that question to this room. Okay. Sorry.
Yes, he needs the microphone.
Okay, well, thank you. That's a good question.
So there was an article recently about a new minor planet that was found in a location that would not exist if we had the 10th planet.
Ah,
And so this is evidence contrary to us having a 10th planet. That doesn't mean it's not there, but
Right.
this is like going in the other direction to proving it.
Okay. Okay, so some negative evidence out there.
Yeah.
All right. Okay, so maybe not. We don't know. But see, we're going to build bigger telescopes. Going to build better telescopes, and we're going to have better equipment.
It's something that is so revolutionary. The Vera Rubin telescope.
Yeah.
If you do anything focus their attention on the Vera Rubin, we're going to be able to see things that we've never seen. Because this thing can literally, what is it, 6 nights?
Paint the sky. Paint the sky.
Southern sky in 6 nights.
Yeah.
And just repeated will image the same area. We're going to find
Vera Rubin.
supernovas,
All kinds of neos. You bring up Vera Rubin, one of the educators that's reviewing their educator activities. One of the activities they're doing is an activity where you actually check out and you measure and you figure out the different types of asteroid based on their orbital elements. And so you can get the Neos, and you can get the Trojans, and you can get the Trans-Neptunians and everything else. So Rubin is going to open the doors, floodgates of discovery.
there's going to be a lot of citizen science projects out of data.
Mhm.
Just like what's been happening with the Webb telescope, citizen science projects participating.
Mhm.
What the NASA website has a lot of listings for where you can classify objects and you can
Mhm.
actually participate in the analysis of the image. The reason I bring up the Vera Rubin is I'm an imager.
Mhm.
And it has the largest digital camera, highest pixel count ever.
Oh, yeah.
At over 1 billion pixels.
Isn't it like 8 billion? Isn't it like 8 billion or something like that? I mean, it's some incredibly huge number.
Yeah. It's more than,
Mhm.
it has a sliding filter system so that they can take like what we call narrowband images, Hubble palette images. And it can take an image in 20 seconds that would take us 35, 45 minutes to 4 hours.
Right.
It's amazing how fast. Everything you
Okay.
could read about it.
Mhm.
Sorry, I'm jumping ahead. Hey, do you think Mars will ever have rings from Phobos reaching the Roche limit?
I don't know, but it makes sense given how we think rings form around other planets, right? Something gets inside the Roche limit, blows up, and makes a nice little ring around the equator eventually. That's one of the things we know about Saturn's rings. They've been there a while because they're all basically in gravitational equilibrium. Almost all of them are in that narrow band, 30 feet wide. It goes around Saturn's equator. So, there, I think it would, I don't know, it would depend. Mars is a lot smaller than Saturn. So whether or not Phobos would actually make a full ring, maybe make like ringlets, kind of like what Neptune has, little droplets on the ring.
And I did have one quick question. That was an excellent presentation, by the way. But you had a link to a PDF towards the end of the presentation.
Yes.
Is that basically a copy of this presentation?
No, it's funny you should mention copy of presentation. I have 20 of them. So so funny you should mention that. So what I'm going to do is I'm going to kind of restrict this to one per family. That's okay, and one per group, so we have enough for everybody to get one. Okay, I'm going to leave them up here along with the giveaways. And I don't know how you guys, within the context of your meeting, how you handle the giveaways, to do that now or later, but I'll leave that one up to you.
Did you go anywhere to see the 2024 solar eclipse?
I did. I went to San Antonio because all the models said, oh, it's going to be clear as heck that day in Texas. And it turns out the places where they predicted the clouds were the places to be, places like Indiana and Buffalo and Cleveland. I mean, who knew I was going to go to Cleveland, for Christ's sake? Anyway, sorry. Forgot I'm still mic'd. Whoop. Okay, go ahead.
Do you think that UFOs are real?
The odds favor it. Okay, and that's all we're going to say about that. The odds favor it. Do we have any hard evidence for the visitation of UFOs? Probably not. Probably not. Oh, nice. Okay. Ouch. Dissing the brother. Oh, it's terrible. Anyway, no, but you think about the elements that make up our bodies, the chemicals that make up our bodies, the hydrogen, the oxygen, the carbon, the nitrogen. Just pulling straight out of Sagan's playbook here, but this is the stuff we're made out of. And it's the same stuff the universe is made out of. So the probability that it's gotten together like this again somewhere else is huge. Then you got another problem called the Fermi paradox. Fermi paradox says we're too far away. They can't reach us. We can't reach them. But we think they're out there. So that's kind of where astronomers are leaning back and forth. They're going between, stop asking silly questions, all the way to, well, if there is alien life, what does it look like? What's swimming in the water under Europa? We don't know. We don't know. It would be really cool to drop a submarine down in there and find out, wouldn't it? Wouldn't that be cool? Maybe you would design the submarine. It's got to melt through the ice and then drop out and deploy cameras and be able to maneuver on Europa. And I'm done.